Okay, so I'm gonna go through this just to get something to you guys quickly. This is the problem from today, talking about the KSP of calcium hydroxide, CaOH2. And so it's telling us that the KSP of calcium hydroxide is 1.3 times 10 to the negative 6th. And it's saying to calculate your molar solubility. You see the word solubility, and you should know that you're going to need an equation for the reaction, right? So you're going to need a solubility equation. So you know that this is a solid, and that it's going to break down into two parts. It's going to break down into calcium and hydroxide. Calcium, so the 2+ charge, this comes from the periodic table, the column that the element is in. You can look up a periodic table with charges on it to kind of help you. As for the charge on this, OH negative, you just kind of need to know that. That's a polyatomic ion, and there's some basic polyatomic ions that we just kind of need to know. So we know that there's only one calcium here. Sorry about that. I live in a camper, and the lights are finicky. So we have one calcium. Okay, so there's only one calcium. That's the charge, not how many there is. Okay, and we see that there's two hydroxides. So we need a 2 as a coefficient over here for our hydroxide to balance the equation. All right, if balancing equations is something that you guys are struggling with, then you need to let me know that too, so that I can go over them a little bit better. I am so sorry for the light. It is just gonna happen. You're gonna have to bear with me. I am gonna do this on the board larger so that you can really see it, but I wanted to get something to you quickly. All right, so now you're gonna write your solubility product, or your SP equation. All right, so KSP is products over reactants, okay, excluding solids and pure liquids, which is why we have no denominator, okay? We only have a numerator. I'm fixing to just turn it off. There, it's just off. Sorry. Okay, so that's why we have no denominator over here. You were like looking at this thing and you're like, where the hell is the denominator? Well, it's not there because your reactants have a solid. So you're gonna disregard your reactants, okay? You're only gonna have your products up top. So here we have our products, calcium with a 2+ charge and hydroxide with a negative charge. And this 2, this squared raised to the second power, comes from the coefficient, i.e. the number in front, of hydroxide. So it's coming from this 2 here. So if this were a 4, you would be raised to the power of 4, okay? All right, so now we're gonna go into our ice table, and we're gonna rewrite our equation down here. Initial change in equilibrium. We're not gonna worry about this, okay? Don't worry about that. Here we have the initial values of 0 and 0. This is because nothing was given. Okay, so we're starting at 0. And we know that we're gonna change by some value, all right? Now, by some value, that could be by the value of a dog turd, okay? It doesn't matter what that value is. We are putting in place an X for that value, okay? The value of X. Over here, this 2 is coming from here, in our equation. Okay, that's where this 2 is coming from. Again, if this was a 4, that would be a 4x. Okay, now why is it an x? You're multiplying by whatever this is. Okay, so it's changing by that value. This value is changing by 2 times that value because of that 2. All right, now we were given no equilibrium value for these, so we're just going to say we don't have these values. So 0 plus x is just x, and 0 plus 2x is just 2x. Plain and simple. Woo! Wham bam, thank you ma'am. Alright, now you have, now you substitute the equilibrium values back into your solubility product, or SP equation, right? So here we bring down, we rewrite the SP equation down here, and we're going to fill in our values. So we know that our equivalency value, or not equivalency, excuse me, equilibrium value of this concentration Ca2 plus is X. Okay, Ca2 plus, that equilibrium concentration, we just have X. So we're going to substitute X in. Okay, so our value OH negative concentration right up here, 2x. So we're going to substitute that directly in. Now don't forget that we have this raised to the power of 2. Okay, so we have to raise it to the power of 2. All right, moving on to the next page, which I have rewritten this. So take a picture of this if you need. All right, moving on. Okay. So now you're going to sub in your KSP for your CaOH2, which was given in the problem, right? So back here in this problem, we were given the KSP of calcium hydroxide is blah, 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 1.3 times 10 to the negative 6th, okay? So now, we've rewritten that equation from the bottom of the previous page. We're going to substitute in this value, 1.3 times 10 to the negative 6th, and this gives us this equation, okay? Now, keep everything in parentheses. I think this is everybody's problem. This is why everybody keeps getting the wrong answers and cannot keep up with where things are going. Okay, keep everything in parentheses. The more parentheses, the better, really. All right, so for instance, let's start over here with this 2x squared term, okay? Anything that's squared is just that multiplied by itself, right? But we have to keep it in its own little brackets, okay? So 2x squared is the same as saying 2x times 2x, okay? Now whenever you solve that expression, 2 times 2 is 4, and x times x is x squared, okay? So you're going to combine 4 and x squared, and that's going to give you 4x squared, all right? You're going to bring down that x, boom, bring down this, boom, and voila, you've got 1.3 times 10 to the negative 6 equals x times 4x squared. Now, let's solve for this expression, okay? X times x squared is x cubed. X times x squared is x cubed. Hopefully everyone has that. So this gives us 4x cubed whenever we solve for this side, okay? Now whenever we see this, hopefully we can also see that it is the same as saying 4 times x cubed, right? So keep this in mind, okay? 4 times x cubed. Our goals are to get x cubed all alone, then to get x all alone, i.e. solve for x. All right, so to get x cubed all alone, you can divide both sides by 4. Why? Boom. It's the same as saying 4 times x cubed. So you divide both sides by 4. Divide both sides by 4. The 4's cancel. 4 divided by 4 is 1. This is the same as saying 1 times x cubed. Okay? So divide both sides by 4. Now, get x all alone. The opposite of an exponent of 3, or a cubic, is to take the cubed root. Okay? So, you take the cubed root, or root 3, however you say it. So many people say it so many different ways. Okay, you take the cubed root of both sides. Those 3's cancel. Cubed root of all of this. Now, notice how I am writing this. I am writing this with each pair of parentheses, okay? Because this is how you're going to put it in your calculator, okay? This is exactly how you would put it into your calculator. Unless you don't have or know how to use a root key that matches what you need, right? So a cubed root has a special key on a lot of calculators, but also a root of anything, a 4th root, a 10th root, a gazillionth root, whatever. This is a blank spot. So a lot of times that symbol will look like this on a key, okay? So this will be, say, a key on your calculator. That's what it'll look like. Okay, if you don't have that or you don't know how to use it on your calculator, there's something you need to know, okay? Unless you don't have a root key that matches, in which case it's important to know that taking a cubed root is the same as raising the expression to the reciprocal power. What does this mean? What the hell does this mean? What is the reciprocal of 3? What is the reciprocal of 3? The reciprocal of 3 is 1/3, right? Because 3 is 3 over 1. Okay? So, to raise the expression to the reciprocal power. So let's come over here. Okay, first take a picture of that. Okay, great. Now let's come over here. Taking the cubed root of all of this, which is x, right? Because we just took the cubed root of x, canceled our 3's, is the same as saying all of this to the power of 1/3, the reciprocal power, okay? Now, for a little bit of side math, okay? This means if solving for x, these are examples, okay? We're going to go through a couple of examples here. Okay, say you're given 1 equals x to the 7th. That means you need to take the 7th root of both sides, okay? The 7th root of both sides. Or you can raise that 1 to the power of the reciprocal 1/7, okay? So same here. 1 to the x, or 1 equals x to the 5th. You need to take the 5th power, or the 5th root, excuse me, of both sides, 5th root of both sides, or take that 1 and raise it to the power of the reciprocal 1 over 5. Okay, here's an example that you can test it for yourself, okay? So, say you were given x squared, and or x squared equals 4, and you were told to find x, okay? So you take the square root of both sides. Square root of 4 is 2, right? Square root of 4 is 2. Well, if you plug into your calculator 4 to the power, don't forget your freaking parentheses. Parentheses. You're going to be like singing it in your brain at night before you go to bed. Parentheses. Okay. To the 1/2. 4 raised to the power of the 1/2. That is going to give you an answer on your calculator of 2. Now, back to the problem at hand. You're going to plug this in to your calculator using your parentheses. Please. Okay? Please, please, please. My dear Aunt Sally. Okay? Parentheses. Use your parentheses. You're going to plug it in. All right. So, my calculator, which I suggest to all of you, it is not very expensive. Okay? It's like $30. It's worth every dollar. Okay? This is how I put it in. That is a -6. My screen is really dirty, sorry. Oh well. I'm not making things any better. So this is how I put it in. I put in what was going to be beneath the bracket first. Okay?